Hello dear students. In the last video we have studied about the monoclinic sulfur. Now let us study about the in the last video we have studied about the rhombic sulfur. Now let us study about the monoclinic sulfur. Monoclinic sulfur is prepared from the rhombic sulfur itself. So now we'll look at the properties of monoclinic sulfur. Monoclinic sulfur is not stable at room temperature. The melting point of monoclinic sulfur is 393 Kelvin. The specific gravity of monoclinic sulfur is 1.98. Monoclinic sulfur is soluble in carbon disulfide. Transition temperature. This is a new term that we need to study about. Both rhombic sulfur, that is alpha sulfur, and monoclinic sulfur, that is beta sulfur, are stable at 369 or 96 degrees centigrade. Below 369 Kelvin or 96 degree centigrade temperature, only alpha sulfur or rhombic sulfur is stable, while above 369 Kelvin or 96 degree centigrade temperature, beta sulfur or monoclinic sulfur is stable. This 369 Kelvin or 96 degree centigrade temperature, where both forms are stable, is called the transition temperature. So this temperature at which both the allotropic forms of sulfur are stable, below that one form is stable, above that temperature another form is stable, that particular temperature at which these forms of sulfur are interconvertible, this temperature is known as the transition temperature. So this is how we know about the various properties and the transition temperature. Now we should study about the structure of the sulfur and its allotropic form. Let's study about the structure of the allotropic forms. Both rhombic sulfur and monoclinic sulfur have S8 molecules. In both the allotropes, S8 molecules are packed differently to give different allotropes. But S8 ring in both the form is puckered and has a crown shape. You can see here that 1, 2, 3, 4, 5, 6, 7, 8 sulfur atoms. They are arranged in the crown shape. The bond angle is 107 degree and the bond length is 204 picometer. This is how both rhombic sulfur and monoclinic sulfur, which exist into S8 molecule structure, and they are available in this crowned shape. The structure of S8 ring in both rhombic sulfur and monoclinic sulfur is shown into the figure. I hope it is understood well. Several other modifications of sulfur containing 6 sulfur atom to 20 sulfur atom per ring have been synthesized in the last 2 decades. So, various other allotropes of sulfur can also be prepared, but this is out of our study. So we have studied about S8 form. Now we want to study about the new form, which is known as Cyclo S6. So in Cyclo S6, the ring adopts the chair conformation on chair form and can be represented as, you can see that this is Cyclo S6. You can see from the picture itself that it is the chair-like structure. So it is known as chair conformation or chair form, in which 1, 2, 3, 4, 5 and 6 sulfur are present. The bond length is 205.7 picometer and the bond angle is 102.2 degree. This is what it is, the structure of S6 ring in Cyclo S6 form of sulfur. At elevated temperatures, the temperature approximately near to 1000 Kelvin, temperature, sulfur exists as S2 dominantly. So it is diatomic molecule of sulfur which is known as S2. Apart from S2, the other forms are also available, but at around 1000 Kelvin, this S2 is dominant. It is the vapor state of sulfur. S2 molecule has two unpaired electrons in anti-bonding pi star orbitals, and that is why S2 is a paramagnetic in nature. So this is a very important point to be remembered about, that this sulfur above approximately around 1000 Kelvin is available as an S2 molecule, which is diatomic molecule, and it is like oxygen molecule. It shows the paramagnetic behavior, or it is paramagnetic in nature because in antibonding pi star orbitals two unpaired electrons are present. I hope, my dear students, you are enjoying your studies. Happy learning.